In the previous videos, we took a look at unit testing and mocking. In this video, we're going to take a look at integration testing. We're still going to take the old approaches of our testing suite being an application that is consuming our other production application. So if you're unfamiliar with that idea, go watch the previous two videos. But in short, you have the application that you're building, and you may have some kind of client consuming it, like JavaScript or maybe other application. Your test suite is just an application just like that, although the purpose of it is to verify that your application behaves in a certain way. So you're just basically scripting user actions. And the primary purpose of it is for you to have confidence that your application works. Okay, so we're still following those principles. For our introductory example, we have an animal class, an animal controller. What do we know about controllers? They're gonna maybe call a database in the end and return some data. This is what we got here. We have our animal DB context. We also have an animal registration service, which we're gonna take a look at later. And then just two interfaces, iEventSync and iSystemClock, just to say, yeah, there might be some kind of other functionality there. So we'll close that. We will bring up the animal controller and we're going to write some tests for it. Let's create a class, animal controller tests. By the way, source code is available. Everything is in the description, links to the previous videos, etc. Right? So animal controllers tests, let's get a fact in here. We'll create a public, a void, and we have a endpoint which returns a bunch of animals. So let's say animal controller lists animals from database. Oh, wrong brackets. Oh, animal controller lists animals from data. I mean, how much more simpler than you get? The point about integration testing is putting multiple components together and building up a suite that allows to do that a little bit easier. As you will see in this example, we're going to have a lot of boilerplate code that will be required in order to set this example up. And then as we're going to produce more tests for this controller, the boilerplate code, a lot of it is going to be repeatable. So compared to the unit tests, what is going to happen is in your integration suite, you're going to have a lot of code that will be very similar to how you write code in a real application. Well, you have your API service where it will have endpoints for specific API methods and maybe parse the request a little bit. You will have the same in your integration tests, although maybe not to that same extent. So anyway, let's go ahead and create a new animal controller. This will require a context. Let's just call this controller, right? And here we'll pass a context. We'll create a context. There it is. We'll need to new this up. An application DB context takes a DB context options. So the way that you create DB context options is through a DB context options builder. In here, we supply our DB context. Let's create options builder. I'll just say new here. In the options builder, what I will do is I'll say use in-memory database. So at the moment, what this is going to do is specifically mock the database component. So the in-memory provider takes away a lot of setup that we otherwise have to include. Later example in this video will kind of show what can happen there. But anyway, this is what we're doing. We're using an in-memory database. I will go to method base, get current method and name to get the name of this method and use it as the in-memory database here. Okay. We can then grab the options builder and pass the options in here, and that will basically fulfill our appdb context. Now, specifically to the appdb context, we have to wrap this in a using statement, because once you spin the DB context up, it will start opening connections to the databases, and once you close it, it will get rid of the context, so any change tracking or anything like that will clear that, right? Anyway, that is too specific to Entity Framework, so we're not going to be talking too much about how to test with Entity Framework. If you're interested about that, I have a couple of other videos on testing, link in the description. It was the voting system series that I did. So anyway, we have the controller here, and we don't really need to put it here. All we want to do is we just want to call list. We then want to put this in a result. This is going to be an iAction result, so let's create a result here, and then we assign it to here. I will reuse these options. Actually, don't need to do it now, but we're going to return a list of animals. At the moment, the list will return an iAction result. That's what it is. How do we extract our list of animals from it? In some of the previous episodes, I showed you how to explore the code and how to sort of find your way. Where do you want to grab the information? What do you mock? We're going to do the same thing here, right? So what is okay? There is an implementation behind every interface. In our case, it's an OK object result, and we pass the value in here. The OK object result inherits from object result. Object result has value in it. Cool. So what we're going to do is we're going to grab the object result name. We're going to go back to our testing here, and we will assert that the result is of type OK object result. So let's go ahead and get our OK result. We will then grab the value. Stop pressing all the wrong buttons. Right, and in here, we'll say that it's animal. So this value should be a list of animals. Okay, and that list, I'm going to say, should only contain one thing. So assert single animals. Oh. There we go. And now we can assert that this animal will have some kind of fields. So assert equals one animal ID. We'll say foo, not food. Animal type, let's say name. And then bar on type. We can also assert not null on the animal itself, although single kind of implies that. I'm just doing it to get rid of the error the ID is showing me. So anyway, here's the setup for the test. And now if we run it, we're gonna see at which point it fails and what more we need to implement. There we go. So we can take a look at this line here, line 27. Collection is empty, so it has no single animal that it can extract from it. We haven't seeded the database, so why should it have, right? Let's grab another using statement up here, which we can then say context, add new animal. And for this animal, we can specify the name foo and type bar. And let's not forget to save changes async. Cool. So if we run this now, there we go. So it passes. The important thing to notice here is this looks an awful lot like a unit test, the things that we've covered before, and partially it is. The thing that separates it from a unit test is the amount of setup that you have to do. So all these things here, if you are adding more components, so if you're even going to add a real database into here, you're gonna have an even more setup. So this is the part where I was saying you're gonna need to abstract, clean away. Same as for the front end, you have your API service class to make sure that all your access to your API, to your backend, is aggregated in this one service. Here, you're gonna need to, use your brain to clean up the test code and make sure that you are interacting with your application through these components that you're gonna be setting up. So you want to improve your developer experience in the test suite. Let's write another endpoint. We're gonna get an animal by ID 1, right? So we're just gonna go ahead and copy this. We're gonna paste it here. We're gonna say gets animal from database, right? A lot of it is going to stay the same. So all we're gonna do is we're gonna say get. We're gonna pass one into here. Let's go ahead, create this action result, should be ID. Let's remove this. We will put one of these here. First our default, and ID should equal ID, right? Simple endpoint, not much is changing here, although we will need to change about this much. animal, and there we go. Let's go ahead and run all of our tests again here. There we go. Obviously, real world, you might not have such simple changes, but what you should understand here is what is the default setup that you're going to use across many of your tests and what is specific to the test. That is just being a good programmer and being able to understand where the abstraction lies, where is the repetition, and how to take it away. So in our case, we might see a different thing. We might call a different endpoint on the controller that we're testing. And depending on the object that it returns, we might need to assert different things. So highlighting these areas, 1, 2, and then a different thing here, 3. This whole setup and the way that we interact with the databases stays the same. So it's up to you how you abstract this really, but it's important to spot these areas and understand that in integration testing, you're going to have a lot more of this setup, and you have to automate the setup for integration testing to be convenient and easy to do. In unit testing, you usually have one unit and one set of tests but the test has many tests, but a set of tests is sort of for that one unit. In integration testing, you're trying to mix and match. And right now for the animal controller, we're only putting an app.db context in there. This is where I'm going to come to the animal registration component, where if you have complicated services which take many other services, here we only have 3, but sometimes we maybe want to mock the system clock and the database. Sometimes we don't want to mock the system clock. We want the real one, or, you got to pick and match. And depending on how complicated your service is or how many services it needs or how deep you want to go. So if we choose to just supply a DB context, we may choose so. With the in-memory database, if we want to test it against a real database, we then go, right, we need this additional setup, maybe create an extension function that basically you just have to call that specifies, I want to use it with this, or you will use class fixtures or collection fixtures, which if you don't know about, we will cover them in a second. But hopefully you get it that your testing suite still remains an application that uses your code, although now in integration testing, you're going to have a lot more setup code, i.e. maybe if it's easier to understand, helper functions to help you test, okay? Because this setup is going to be repeatable as you are going to be, composing components together. And the better your abstractions are, the easier it will be to compose them together, the less code you will have to write in your integration test. Now, putting this example aside, let's go ahead and take a look at the database example, as it's a little bit closer to the real world and maybe you will find it a little bit more useful. And here we have an animal, something that I'm going to grab from the database. We then have an animal store, so an iAnimal store interface, which is a repository, and then an implementation for it. The implementation doesn't matter too much. You can go over it in your own time. I will probably cover it briefly, but we'll see how it goes. It's basically a repository that has a database injected into it. So a Postgres database which has an iDatabase interface, and the iDatabase interface is what's injected into the store. Right, so the PostgreSQL database itself has a connection which we can put inside of it. And I mean, that's already kind of like 3 layers of, components being put together. Additionally to that, because I'm using a real database, there is going to be an outside component of a database coming with it. So there's a bit here to spawn my connections from a connection factory, and then there's also a database setup, which I just put it here for now because I haven't written the tests yet, and I just don't want. I'm going to be copying this code, and that will just save me a bit of time and get to the point here. Okay, so actually let me leave that open, and let's go ahead and write animal database tests. So I'll add that to Git. Now, as we have quite a few layers in here, let's go ahead and just introduce it one by one so you understand the bigger picture a little bit more clearly. So public void, and we'll just call it do for now because we're just playing around. At the moment, I have this database setup class, which is really part of the test suite. So not into components, but rather into integration tests here. And this is something that you would have to write to like create the database or tear it down at the end of the test. And I mean, if you're using Entity Framework, that's gonna be done for you kind of thing. These methods will be implemented. You still have to call them. Nevertheless, this is what I have here. I also have a couple of connection strings here that I'm just gonna grab and put them here. Let's go ahead and use these functions. So let me just change the namespace here. I will grab the database. We'll go into do. And in here, we're going to go ahead and call create database. We're going to pass a connection to it and the database that we want to create. We'll then call await on it. We'll make the function a task async. And first we connect to the PostgreSQL server on itself, and then we create the test database in there, okay? And then with the delete database, we would be tearing it down. So on my other screen here, I am going to have my terminal. I have a PostgreSQL server running locally in my WSL2 instance. If you want to know how to do that, go ahead, link in the description. I have a video on how to set that up. In here, if I go ahead and list databases, I don't have the one for testDB here. This is what it's called. So let's go ahead and run this. This internally is going to create the database, and it's going to create an animal table in there. So I have an error there. Yeah, I've passed the wrong connection. So I try to connect with a connection string that has the test database in there. So that doesn't exist yet. So I'm just going to run it again, and yeah, should be no problem there. So that passed. Obviously, we're not asserting anything, but the point is, if I list now, I have my testDB. So just so you have in your mind, I spin up a database purely for testing, and I'm then going to go ahead and tear it down as well. So we can then go ahead and call delete database. It will do something along the right lines of delete drop drop a database, and we'll call testDB. All right, and then if we list this again, our database is gone. It's going to close connections, and then it's going to drop the database. Cool. So now if I run my database, or sorry, my test, just successful. And if I list, I don't have my database in there, right? So clean test every single time. If I want to, I can replace this testDB with a GUID or a newly generated random name. Although I'm not going to do it for this specific example, because that's not the hard bit about this. Let's go ahead and keep arranging this into an example where we can see it work. This is something that we need to do before and after our test. Okay. Ideally, we want to then offload that to be run before and after every test by the testing framework. All right. So the testing framework should support us in this endeavor. Close this database setup. And what we want to do now is, again, just go to the class that we're really testing. We all know how a repository works. Let's just go ahead, create a repository, and work from there, right? We're going to call a function on it. It's going to grab some data from the database, right? Not much to it. Let's grab our animal store, have an animal store, and a new animal store. We will need a database in here. Let's go ahead and create a local database, and we'll put a new Postgres in here. And here we'll need a connection. The connection will come from here, and here we'll have Postgres connection factory. And I mean, yeah, let's call it new, and we'll create here. Inside of here, we'll need to put a connection string, which we'll add here, and this will need to be async await. All right. And I mean, I guess what happens inside the connection factory is, I don't know what all those spaces are about, but we put a connection string in here and we create a single connection. So we asynchronously resolve a connection. And I mean, this is not async safe, like either locking or semaphore or something like that, to prevent opening like multiple connections. But this will yield a connection, which we can then inject into the database, or this can be done during the PostgreSQL database in here as well. But I mean, because it's asynchronous, it doesn't matter, it's implementation detail. And then we have a dispose here as well. So let's go ahead and just quickly put the factory, connection factory, right? That's the name. We'll use it here. It will still have the reference, and at the end we will want to dispose of it as well. Okay, so this is not that important to us either. It should be, it's like, in the grand scheme of the application, it is going to be part of the pipeline, part of the middle, where once the PostgreSQL service gets resolved, this should create the connection, and once it gets disposed of, it should dispose the connection, and you know, a typical life cycle of the service. Let's go ahead and try to see this work as well. In the store, we're going to try to save an animal. So we're going to pass a new animal. The ID doesn't matter because it's going to be incremented sequentially. We're going to go foo bar and await on this. That's, I think, a reasonable test. Let's call it writes or animal store saves animal record to database, right? To database, yeah. That'll be good. Now, at this point, you may, all right, we've saved something. How do we check that it retrieves it as well? I'm going to say that what we can do is we can still use the store to verify this action as well, or we can use the PostgreSQL client. So there are two approaches here. I would say I want to lean on the store. So let's go ahead and we will get a bunch of animals. Let's go ahead and store these animals in here. And I will say the same thing here. Animals, or let's say kind of similar to what we did previously. So single animals. And let me go ahead and quickly copy these assertions so I don't want to write them again. Put them here. We will close the connection here, because if this does fail, I don't want it to leave anything open and not clean up the database. So it actually happens here. Okay, let's go ahead and run this test. So all of this passes, the database in the end, it gets cleaned up as well. We can take a look at how this happens internally as well. There are ways you can write a custom query here, and basically this is closer to black box testing, because we have this repository. So we input something into the repository and then we query something on the other end of the repository, and we don't look at the database or anything underneath the layers. If we want to go into white box testing, if it's going to make you more confident by looking in the PostgreSQL database, if you are then going to have like something like a helper function or in here as part of your suite to basically go behind into the database and do something along the lines of like list connections. Okay, let's go in here and we will list our relationships and select all animals, and then we're gonna have our animal, right? So if you want to have a custom query going into the database and querying it, that option is still available. But this is, however, an example closer being to black box testing, where we're only interacting it through this closed layer, which protects all the internals of the database and other abstractions that are going on here. So let's continue and do something along the lines of this. We'll grab this, and we're also going to test gets animal store, gets animal, gets saved animal by ID from database. A little bit of whatever, right? What do we want to do? We want to go into get animals. Again, it's going to be a similar story where we're just going to get an animal. We're going to get an animal by ID 1. We're going to have this animal here. We're going to assert not null on the animal. Okay, and let's run our test here. Okay, so that's because I haven't deleted it previously. You can see that it's still there. Let me go ahead and quit the database here. I should have just disconnected, but what are we doing here? So drop database test db. There we go, right? So just drop the database there, just going to rerun this again. And this error, yeah, operator, it looks like I've just messed this up a little bit. Let's see, PostgreSQL, where I pass parameters. Yeah, don't do that. Let's see, in the animal store, so when I get the animal, I had to string the ID, okay, yeah. It's a silly Billy mistake. Let's just quickly refactor this to be, instead of string, object. Next. Cool. That should be fine there. What does this leave us with here? Yep, that's fine. Let's go ahead and run this. We might still have the database. Yep, because it's dropped. So there's one problem with having all of this and, you know, like not cleaning up the database from outside of the scope of the test. We're just gonna quickly get this working and or make sure that it's working. We'll move on to the next part of creating fixtures and how that's gonna look. Just making sure nothing's left over here. Yep, so that is ran. We can run both or all the tests here and see what happens. And this actually brings us nicely over to the next point, where basically what is happening here is in the delete database call, since I'm deleting this single database that I have here multiple times, I am hard terminating a connection to this database. So what you want to end up with is a single database for both of these tests. Let's go ahead and see how we can achieve that. We're going to create a collection fixture, or let's actually start with a class fixture because we only have one class. Let's create a PostgreSQL fixture. Yeah, that'll be good. And in this class, what we want to do is we want to do our setup and our teardown. So let's take a look at how much are we doing. So we will need to create a database, maybe up to here where we have the connection, and then we seed it into the PostgreSQL database. Let's go ahead and grab this. We'll create a public void do for now, just saving this stuff here. We will need this async. All right, let's maybe about that much. We'll need our connection strings, so let's grab those. Let's actually grab all of the connection strings here, just like that. Let's grab all of our imports, and the database, let's make it global, right? So these can be turned private. Just quickly do that. We will then create a prop of database. We can make a private setter, because that is what we're going to be assigning in this function here. Notice that it is async, so this is so we're not putting it in a constructor. Xunit has an iasync lifetime interface, which gives us initialize async and dispose async functions, right? So this is where we put our async initialization in the initialize async function here. Let's make this asynchronous, right? And this is where we create the database. And for our teardown, we want to dispose of the connection in Looney Tunes. In our dispose async, we do need access to our connection factory here. So let's go ahead and make this a field. Create a field. Read only. There we go. Connection factory here. Read only, actually can't have it read only. And then we can use the connection factory here. Remove this elongated name. And there we go. So we initialize this fixture and then we dispose of it. At the end of the day, what we want to do is we want to supply a class fixture of PostgreSQL fixture. And now we can accept it in the constructor. So xunit will take care of creating this connection for us, and then once our tests run, it will dispose of it. All right. There are a couple of things that you gotta watch out here for, so we'll talk about it in a second. Right. Let's call it by its full name. So in here, from our PostgreSQL fixture, we grab the database, the almighty. There we go, right? I think this can be part of the setup. We still have the store, and then more or less the same thing will happen here. Let's grab this. We will get rid of most of the setup. We don't need this connection factory. And let's see what happens now. Okay, so that's a bit of a bummer. We'll need to delete this. Let's run this again. Cool. So the collection contained more than one element. And this is for the saves animal to database. So it's this bit here. So what happened here was that the get animals, this test got infiltrated by this other test. This is generally going to be the case when you are sharing a database instance. It's shared state, so you cannot expect it to be unique all the time. What you can do is you can set it up in a way where it will be set up for this specific set of tests. So what you do is you go to your PostgreSQL fixture, you do something along the lines of, let's actually rename it here. We will call it animal setup fixture. Yep. And once we create the database here, what we do is we actually seed it to make sure that we set it up for other tests as well. So let's actually go ahead and grab this store here. We can go ahead, set it up here. We'll create a public task seed, okay? And this is where we can do something along the lines of this. On the, let's call the await here and the store. Let's go ahead and do the same thing with it we did with the database here. So let's go ahead and create iAnimal store with a private set. Animal fixture database, we no longer pass that, we just pass the database. So chances are we don't even need to pass the database anymore. We just go ahead and make this a private field as well. Okay. Database. There we go. And let's just set this here, or actually pop it over there. I don't think I will need to do anything there. On the store here, yeah, let's create a database here. Let me just do a bunch of this stuff. Store, yeah, sorry, store starts with a big S. And there we go. So now what we do is we operate on the store. So let's go ahead and do something along the, we no longer need to actually do this save because that's part of the setup step. So we offload that to the fixture. We then go to the animal setup fixture. We go to the store and we get the animals. And I forgot this was a saves animal to the store logic. Right, let me pass this here. Sorry, just let me quickly clean this up. Right, let's delete this original store. Quickly put this back here as well. This assertion may no longer be valid. What we're specifically looking for is a single, let's say, instead of supplying foo, we will just make sure that we're always generating a unique name. So you do something along the lines of this. You pass the name here. Okay. And then when you go to check it, you make sure that the name that you're grabbing equals to the name. So there is a single one. So you're kind of offsetting. You're not doing it by an ID that you're doing here. If you're saving this, you might be saving some other. So the ID, you can assert that it's more than 0. This one doesn't really matter too much because we're already know we're getting it by that thing. And yeah, this should throw it, and the type is bar. So just in case you get the wrong good, but this also really doesn't matter. You can check it if you want, but it doesn't really matter at this point because we will be verifying it through this mechanism. Let's move over to this test as well now. Let's grab this store. We will no longer need to seed this animal. We know that under the ID of 1 is the one that we've seeded here. So we can treat it positionally based. Why do I have this function here? Let's go ahead, grab it. put it here. Okay, get the first one, and this should be fine. So let's go ahead and run this. Really didn't expect this one to happen. Let me double check on the seed. You know, the very important thing is that you actually, you know, set your tests up correctly. So yeah, running these again works fine. So not the ideal solution, I would say, although hopefully this gives you an idea in which direction you want to go in. You can see how much bulk we reduced in these tests by offloading a setup here and still making it work and still giving us the confidence that it works. Ideally, you would do something like animal setup fixture database, or you know, you name your database relevant to what it is, and then you can go ahead and use it somewhere else. Now, chances are you are gonna need a fixture that spans across multiple test classes. In this case, what you can do is you can use a collection fixture. How a collection fixture works is, instead of having an iClass fixture, so at the moment this class is scoped to this particular class. So if we would create a second class and we would pop this iClass fixture on there, we would get the same problem, because already on the database side we said that block all connections to this database, so we can go ahead and drop it. What you can do is you can use a collection fixture. Let's go ahead and port this to a collection fixture. Create our new class, animal collection. This will be an iCollection fixture, and same as a class fixture, we tell what belongs to this collection. And animal setup fixture, so this now belongs to this collection. We then go ahead and tag it to something like collection definition, and we can say name of this particular class, and that's pretty much it. So now anything that you tag with this will have access to the animal setup fixture. So if we go to the animal database test, so yeah, back here, I will comment this out for future references. And what I will do here is I will create a collection tag, and I will just use the animal collection class. Okay, this should now inject the animal setup fixture, because I mean that's basically the model that xunit people took. This is how this is gonna work. You need a class to share across all your tests. You create a collection of it, you give it a name, and then you basically specify the attribute on the place where you want to inject it. Now, if we go ahead and run these tests, they all pass. What we can then further do is, let's say, animal database query test. This is just to kind of show you that that's how it works. Let's go ahead, grab the collection, put it on here. Let's grab maybe one of these tests. We'll put them here. We'll import this task, animal setup fixture. We'll grab that as well. Let's grab it from here. Put it at the top here. Animal database query tests. Animal store lists animals from database. Here, what I'm going to do is I'll do something like foo bar baz, and in the list animals from database, I will say that get animals. We're seeding 3, so we should have at least 3 animals that we retrieve from the database, and we should have contains animals, something along the lines of a name equals foo. 3 of these will have bar and baz as well. Okay, and there we go. So hopefully you get the picture. Your integration tests, they do not have to be big either. What you're gonna have is you're gonna have all these setups, all this additional stuff that is basically going to make the arrangement of your components predefined. So you have a fixture that basically says how you arrange your components, and then you use that arrangement in your tests. Hopefully you've enjoyed this video. If you did, leave a like, subscribe. If you would like to support this channel, I have now opened the shop. I'll be adding more products in the future, but you can visit a link in the description. If you have any questions, you know you can reach out to me in the comments section or on my Discord server. I also stream on Wednesdays and Sundays on Twitch. Again, links in the description, and hope to see you in my other videos.